Compute the following derivative. So we know that when we have a radical, we can write it as power over root. So what we have on the inside here is x cubed minus x squared, right, to the 1/2 power. And the way we do this is, say you have x to any power, we'll say x to the 4th, and we'll take the 5th root of that. To write this in a more easier, more, better looking way, you can write x to the power, whichever power it's at, power over root. So that's kind of how you can rewrite these things. And these are completely equal. So now that we have this, we can take the derivative, which is moving the exponent down. So we'll move the exponent down, and then we subtract 1 over here. Subtract 1 from the exponent. So when we do this, we get that 1/2 times the inside, and then 1/2 minus 1 is negative 1/2. Okay? So when you take the derivative, you do the outside derivative first, outside, and then keep this blob, right? And then multiply by the derivative of the inside. So pretend like this right here is just one figure. Pretend it doesn't exist, So take the derivative like normal, where you'd move the exponent to the front, and then you subtract from the exponent, and then you keep your blob the same. The only thing that we're doing to this specific derivative is that we're multiplying by the derivative. And when we take the derivative of the inside, we get 3x squared minus 2x. Okay? dx. So that's what we get when we take the derivative. And this is your answer. But if certain teachers would like you to simplify it more because this doesn't look very neat, you could organize it. So we know that this is to a negative 1/2 exponent. So we can rewrite this in the denominator. So you can actually write this as x cubed minus x squared. And then now this is in the denominator, because now we just flip this. We put it in the denominator, and now it's to the positive 1/2 power. And then we'll put a 2 in front because of this 1/2 here. And then all we have left up top is 3x squared minus 2x dx. And you could say you're done there too, but there's more that you can do to this. If you notice that this x cubed and this x squared have in common, you can pull out, or you can factor out a common x squared between the two. So we have a 2 times, we'll put this back into a square root so it's easier to see, right? So this is multiplied. We can pull out the x squared, and we're left with x minus 1. Does that make sense? Right? So all I did was turn this 1/2 exponent back into a radical, and then I pulled out this x squared out of both of them, and we're left with x minus 1. All right? So we're still left with 3x squared minus 2x dx on the top. And then we can actually go a little bit further by taking the square root of a square, and we're just left with x, right? So let's put a line up here. So we get 3x squared minus 2x, and then on the denominator we have 2 times x times the square root of x minus 1, right? Because we took the square root. When you have a radical here and there's a multiplication, you can split them up. And so the square root of x squared is equal to x, okay? And then this x is in the denominator, so we can actually cancel one of the x's out here and x's out here. And then we're left with 3x minus 2 all over 2, and now this x is canceled out, x minus 1. Alrighty, hope this was helpful.